volume. It is also called as strain energy density. And this energy dissipated should also be considered during the calculation of for crystallite size as well as the microstrain. Hence, this model is basically in terms of energy density, and one can use to calculate the dislocation density of a sample by using this Williamson-Hall uniform deformation energy density model. Then the next slide basically shows the parameters using Scherrer method. We have calculated average crystallite size, microstrain and dislocation density. Then the next plot is for the concentration of vanadium precursor, which is on the x-axis, and the crystallite size on the y-axis. As we can see from the plot, that as the concentration of vanadium precursor goes on increasing, the crystallite size keeps on decreasing. Similarly, the microstrain keeps on increasing whenever we increase the precursor concentration. Then the next slide is the structural parameter obtained using WH method. Presentation is that vanadium pentoxide nanomaterials were grown using hydrothermal method. These syntheses were carried out at different concentrations of vanadium source. Then the microstructural investigations were carried out using XRD technique. Structural parameters such as crystallite size due to the fact that higher concentration results in more nucleation centers. And the valuation obtained from WH methods differs from Scherrer method. This could be the contribution from microstrain, which we have neglected in Scherrer model. That's all, sir.
Rest of the participants.
Pardon, sir?
Yeah. First, Rupin.
Yes, sir.
Let me know one thing. Are you PhD student?
Yes, sir.
Okay. Which year of PhD student?
Second year.
Okay, okay. From which university?
Pune University. Sir, it is used in supercapacitors as well as in batteries, sir.
Yeah. One thing. There are someone, I think, making noise. I don't know whether it is coming from your side.
No, sir, not from my side.
Yeah. See, that what is the why you are chosen only hydrothermally grown method and so many other methods are there? Why you are giving preference for this? Yes. Are you getting my question, Rupin? Are you getting my question?
Yes, sir. You had asked about hydrothermal method, right?
Yes. Why? What is the why you have chosen that method over other methods are available?
Sir, actually, the reason is we can get, sir, nanomaterials of very perfect morphology in case of hydrothermal synthesis as compared to other methods. The morphology is good.
Yeah, yeah. You have to actually come to the projection. Camera projection is not correct.
Now is it fine, sir?
Okay. I think a lot of sound is coming from your side. Lot of sound is there from your side.
Okay, just a minute. I'll put my headphones on, sir.
See, one thing I would like to know, what is the major novelty in this? See, actually, a lot of literature is there on vanadium pentoxide. What is the novelty in your work? Are you getting my voice? Hello. Okay, then fine. Your time is over. Okay, Rupin. Yeah, actually,
yes,
your
sir.
session is. Yeah, you can log out. It's over.
Okay, thank you, sir. Thank you, sir. Okay.
You can see. Now, I request all these participants. First, you have to follow the given session. This is now third year. Now we are giving importance to this particular session, students, and we are going in the order. So Is there Mr. Mandeep Singh? Manideep Singh is there? Manideep Singh, you know. Next, Lipsananda. Lipsananda. Yes, Lipsananda. Lipsananda is there. Oh, what is this? They are there. Nobody is responding. Hello, Lipsa. Yeah. See, please come on. Now I have to make her present. So right click, change it. Make it, please. Yes. Thank you. Lipsananda, now you are presented. Upload your slide.
Hello, sir.
Yeah,
Hello,
upload.
sir. Am I audible?
Yes, audible.
Yes.
Please proceed.
Yes, sir. Uh, is my presentation visible, sir?
Not
Hello?
yet. Not yet. Not yet. Yes, Lipsananda.
Is it visible?
Yeah.
Is it visible, sir?
Yes, yes.
Is the presentation visible?
Yeah. Proceed.
Good afternoon,
No.
everyone.
Wait. From your side.
Myself, Dr. Lipsa.
From your side, network is not at.
Yes, sir. The network is not stable, sir.
Yes, even a slide is not appearing properly for me. It looks blurry only.
Is it visible, sir? Hello?
Yeah. Proceed.
Good afternoon, unique problem.
Your slide is actually in very poor condition. Dr. Ramesh, please close your video, please. Yeah. You continue, Dr. Ipsananda. Yeah.
Model.
Something problem is there from your network, please. Please check and continue. I am not audible to you. I am not getting any voice from you. It is breaking.
Am I audible now, sir?
Yeah. But your slide is not loaded. Again,
Am I
you
audible,
refresh
sir?
and load. Your slide is not properly loaded. Please check again. Okay, shall I switch to other student? If some network problem is there from your side? Because we are running short of
There is
time.
some network issues in WebEx, but I think this works in Google Meet.
No, I cannot switch our network now immediately. It's difficult for me. We are in the WebEx. The rest of the other students are waiting for me. Okay, time being, we are stopping you. We'll come back to you. at the end after the rest of the session. Okay, now I am closing for you.
So is it not visible yet?
No, your PPT is not loaded. That is the issue now. We are facing some from your side. Some network problem is there. Your screen is empty. Now, Miss Natasha Mandal. Natasha Mandal is there.
Okay, sir.
Natasha Mandal is there. Natasha Mandal. Okay. Now we are switching to the other. Pankaj Biswas. Pankaj Biswas. Pankaj Biswas is there. Pankaj Biswas. Pankaj Biswas, you are the presenter now. Please load your PPT. Pankaj Biswas. Please load your, yeah.
Hello, sir. Am I audible, sir?
Yeah. Yeah, proceed. Proceed, please.
Sir, is my PPT visible to you?
Yes, yes. Proceed.
Okay. Good afternoon to you one and all. Myself, Dr. Pankaj Biswas, Assistant Professor, School of Physics, Shri Mata Vaishnavi University. Today, I am going to present my work on structural luminescence properties of bulk KSR VO4 samarium phosphor, samarium doped phosphor for amber LED applications. Next, it is not proceeding. Yes. The general outline of my work is introduction, followed by motivation, objectives, methodology, sample preparation, characterization, then results and discussion, followed by conclusions. As we know, the phosphors are the luminescent materials which, when excited by some external higher energy, they convert it into the electromagnetic wave falling into the lower your higher wavelength region. And there is the Stokes shift, which is usually seen through these materials. The excitation energy usually is in the UV range, and the emission takes place in the visible range, which is of lower wavelength. The reverse may also occur whenever it is excited by higher wavelength and the energy comes in the visible region. And we have also the rare earth elements, which are the main dopants in these materials. And the transition of rare earth ions we know quite well, because rare earth transitions are favorable for luminescence, and the emission takes place from UV to near IR region. And they are finding very large or wide variety of applications in lasers, in displays, in LEDs, in lamps, in dosimeters. Rare earth emissions are of two types mainly. One is the 4F transitions, which are very sharp emission lines having full width half maximum less than 10 nanometer, and largely it is independent of the host, because the 4F's intra-shell configurations are shielded by the outer 5s 5p orbitals. And we also have the ground state 4F your DF emitters, 5D 4F emission, in which emission bands are quite wide, with the condition that they are strongly dependent on the host. Host environment also influence these rare earth ions. Actually,
Yes, one thing, Dr.
yes.
Biswas,
Yes.
Don't spend too much of time on the introduction itself.
Okay.
See,
Okay.
we want, yeah, you connect to the what is the objective
Okay.
of
Well,
the final results we will discuss.
okay, which have chosen ortho vanadiates because these are very good quality of host material, which have the ability to entertain wide range of rare earth to make the phosphors. The phosphor we choose of the type AbVO4 Re3+, where Re we can replace with the samarium, your europium, uh, samarium or holmium, whatever the case. Phosphors have wide variety of applications, as I already have told you. The motivation behind the work is that the indium gallium nitride or gallium nitride based LEDs emit in the UV region, and UV can be exploited for emitting emission in the visible region through these phosphors, because UV is the higher energy, and with the help of phosphors we can emit in the lower energy region. And you can see here the silicon and germanium are not suitable for formation of such LEDs, and the energy from these LEDs can be tailored. Like we can just tailor between the indium and the gallium content to make the color to be different for different energies. And the we have actually there is some kind of gap called the yellow gap, which is the motivation behind this work, that which falls within this range 530 to 600 nanometer range, because gallium indium nitride chips, they emit in this 350 to 500 nanometer region, whereas aluminum gallium indium phosphide, the quaternary LEDs, emit in the 600 onward region, and in between there is the gap from the natural LEDs, and this gap can be fulfilled with the help of the phosphor converted LEDs, where we coat the material with the phosphor and they emit in the visible region. Based upon the motivation, the following objectives were made. Like we synthesized the bulk phase phosphor KSRBF for samarium using solid state reaction method, and to characterize these phosphor which are prepared for structural and morphological studies, and then to study their photoluminescence and the spectral characteristic in order to find their optimum concentration in the host material by studying the emission excitation spectrum, and to correlate the PL results so far with the the same phosphor prepared with other techniques. The methodology behind is quite simple. We prepared samples using solid state reaction method, in which the carbonates of the precursors as carbonates are put at the starting material. They were ground for 1 hour in the mortar pestle, and then they were then heat treated at 400 degrees Celsius for 4 hours. And after that, they are again grinded for 20 minutes and the subjected to heat at 900 degrees Celsius for 4 hours. Finally, the fine ground powder was obtained, and this took place in a very short time, 20 minutes and 1 hour. You can see there, but the heat treating takes long time. It may take 1 day or 2 days as a whole. And the prepared phosphors were then preserved into the vials for further characterization. Characterization used were X-ray powder diffraction method, which confirms the phase formation and determines the particle size using WH technique, and Williamson Hall technique. And we have the photoluminescence technique also, where emission and excitation spectrum were recorded, which optimize the dopant concentration into the host. Dopant here is samarium, the host is the KSRBO4. The energy transfer mechanism was also studied from using this photoluminescence technique. UV spectroscopy was employed for determining the band gap using the diffuse reflectance spectrum when the conversion to absorption using Kobilka-Monk function was incurred. Now we have the X-ray diffraction. We can see the X-ray diffraction plot pattern is quite in resemblance with the JCPDS card number as shown in the figure, and the studies show that the phosphor crystallizes into the orthorhombic structure with the space group P and MA. The lattice parameters and the volume all were calculated, followed by the Williamson Hall plot, where we have the crystallite size estimation along with the microstrain calculation, and this is the Williamson Hall equation, in the y equal to mx plus c format, where the slope and the reciprocal of this gave the grain size and microstrain. And grain size was obtained to be 267.69 nanometer, which is in the micrometer regime. And the microstrain was also of the order of 10 power minus 3. The optical band gap was determined where the DRS plot was obtained, and the DRS studies was used to convert the data from reflectance spectrum to the absorption spectrum. This is the Kubelka-Monk absorption function, which
yeah. So those and all routine formulas and all fixed formulas in the tool and all.
Yes.
Come to your point, your subject point of view. What is that value?
Oh, yes. Here we have found
Presentation is time limited. Presentation is time limited, and
Okay,
at the same time you have to carry your
Yes.
message. Yeah. Proceed.
The Kubelka-Monk function converts diffuse reflectance to absorption, and using this equation, the torque plot was plotted where for directly allowed transition, the band gap of the phosphor was found out to be 3.48 electron volt, which is quite wide for entertaining the energy levels of the rare earth ions. Then we have the photoluminescence technique, which we exploited for PL excitation emission spectrum determination. As we can see here, the excitation spectrum shown in the blue color has a peak around the 400 nanometer and one CTB charge transfer band about 300 nanometer. We exploited this 400 nanometer absorption from the UV emitted by the indium gallium nitride based LED chips. That can be used to excite this phosphor and to emit in the 600 nanometer or this 600 nanometer and 646 nanometer, the orange red region. Here, the prominent 600 nanometer emission is ascribed to the 4G 5/2 6H7/2 characteristic emission of the samarium. And this emission obtained was quite enhanced, which projects this phosphor to be suitable for the bright displays applications. And the concentration quenching effect was also studied, where with the concentration change in the phosphor, the PL intensity was recorded, and we had seen the phosphor was optimized at 1.5 mole % concentration in this kind of phase.
Yeah.
Phase.
Yeah, understood. Proceed to the next quickly.
Then the decay curve was also plotted.
Your time is over.
Okay, decay curve shows very large effective time of decay, and the time kind of equation as shown was used, and effective time was about 1.016 milliseconds, which is quite good in our view. Non-radiative energy transfer was also studied, where we have found the multipolar interaction taking place between the activator ions, which were responsible for the non-radiative transitions. And from the slope, reciprocal of the slope, we found out the kind of interaction between the activator ions to be dipole-dipole interactions. And the CIA color coordinates were also obtained. In the color gamut, you see it is about 0.61 and 0.39. Okay, these XY coordinates are used to just obtain the CCT temperature, which is color colority temperature about 6000 Kelvin. And this also validates the dominant wavelength of the phosphor to be 600 nanometer, which is found at the edge of the color gamut. And from the studies, we draw the conclusion that the narrow excitation band in the UV region, about 400 nanometer in the absorption spectrum of this title phosphor, can be predominantly used for just getting the characteristic samarium emissions about 600 nanometer, which is in the visible region. And this suggests that the phosphor has the potential to meet the high efficiency requirement of filling that amber gap, which is found by the Miller mark in their paper. Thank you, sir.
Okay, fine. I would like to ask you a few questions about this.
Yes, sir.
Please open your video.
Yes, sir. Video? Okay.
Yeah. Let me see that.
Okay. Just wait for a while. Actually, bandwidth become quite low. Yes, sir. Sir.
Yeah. Pankaj, what is the wavelength of the LED for which you are synthesized and characterized. What is the wavelength for which you are synthesized and characterized this particular material? Are you synthesized this bulk material of this one?
This is the actually we use the precursor materials for preparation of this phosphor using solid state reaction method.
Hmm.
Hello, sir.
Okay.
Am I audible?
Yes, yes, I am getting. Yeah.
And we
What
excited
is
the phosphor with the help of 400 nanometer, and we got emission around 600 nanometer. The high energy is converted to the lower energy. High energy is the invisible energy. Lower energy is the visible one.
Okay.
And this can be a potential phosphor to fill the amber gap, which was found in the paper as reported by Miller and Mark. This was the motivation behind the work.
Okay. Is it direct band gap material or indirect band gap material?
This is the direct band gap material.
Okay. What is the band gap of that?
Band gap is 3.48 nanometer.
3.48 nanometer.
Yes.
Okay, okay, fine. So, yeah, what is something special about this?
Something special about is that the very impurity peaks were missing in this case because we heat treat the material before calcination. We heat treat the material at 400 degrees Celsius for 4 hours, which remove the impurities present in the precursors. Whereas in the combustion method, we also executed that where the time is very short. Within 3 to 5 seconds, the whole of the process undergo completion, and some precursor impurities are prevalent within the title compound, and they were obtained as the XRD peaks.
Fine,
Yes.
fine, fine. See, one thing. I think you are the presenting author, and is it your PhD student's work or something? You are the only.
This is my work itself. Out of the
Okay.
sheer excitement, I just tried it as it's new. The first.
Okay.
Okay.
It is a good thing. I hope that you are submitted.
I have already submitted. I am assistant
Okay.
professor in School of Physics, Shri Mata
Yes.
Vaishnav University, sir.
Yeah, fine. Okay, thank you, Dr. Biswas.
Okay, welcome, sir. Welcome.
Okay, fine. You can exit.
Thank you, sir. Thank you.
Yeah. So now, Prashant Chilpodi. Prashant Chilpodi. Is there? Please. Is there Prashant Chilpodi? Yeah. Then next, Miss Mita Ben Lad. Miss Mita Ben Lad. Is it available? Miss Mita Ben Lad. Yes. Okay, Mita. Wait for a while. I will make you presenter. Mita. See, what two IDs are there? You are Mithal Ben Lad, right? Actually, two are there. In one ID, Mithal Lad is there. Mithal U Lad. Which one you are here? You are opened, I think, two things. E1002. Okay. So now you are in, I think, which ID? You have created two IDs. Shall I open any one of the thing? Whether Mithal Lad, okay, fine. I will open that one. Mithal Lad. Okay, you are the presenter now. Please proceed.
Hello.
Yeah, you are presenter now. Please proceed. Mithal. Mithal, you led. Yeah, first open your video. Let me see. And then you can proceed. Yeah. Can you open your video once? Then we can proceed.
Just a minute, sir.
Yeah. So you are you PhD student or
PhD student
yeah? Which year of PhD student?
from Veer Narbat, South Gujarat University, Surat.
Oh, okay. Which year you are now?
Sorry, sir.
Which year you are studying now? Third year, first year, second year?
Second.
Second year.
Second.
Okay, from physics department.
Yes.
Yes. Now you can proceed now. You can proceed your presentation now. 5 minutes time is there. Another 2 minutes. We will.
Okay. I'm here to present studies of structural and optical properties. It is of just a minute.
This is even 0002, right?
Yes. Actually, I have changed.
Mm-hmm.
Yes, I'm. मम्मी ये अपने ये हेडफोन अपनी हमें चाहिए थैंक यू डबल वॉल्यूम संभळाय છે हेलो
Yeah, proceed. Proceed, Meta.
हेलो
Yeah, proceed, please.
हेलो
Yeah, I am listening. I am getting your voice. You can proceed further.
हेलो
Otherwise, close your video. Please, please close your video and proceed
am I
with your
audible sir
presentation. Yes, yes, I am getting. You close your video.
હવે શું કરું
Please close your video. Proceed with presentation.
ડબલ અવાજ સંભળાતો હતો એટલે.
Yeah, time is running short. You cannot take. Otherwise,
Hello?
please you re-upload.
Okay.
Refresh and re-upload. Otherwise, you close your video. Yes, proceed. Close your video.
Yeah, just a minute. Hello.
Yeah, please proceed. Please proceed. I am getting. Please proceed.
Yes. Studies of structural and optical properties of nickel chloride and glycine doped potassium hydrogen thalate crystal. Introduction. Due to the variety of applications, including optical
Yeah.
computing,
See,
data.
Mithal,
Yeah. Yeah.
your present. Where is your presentation? You are showing me your email. Your email box I am seeing. Your presentation I am not
Oh.
getting.
Uh, Now, sir.
Yes, yes, proceed. Yeah, you are taking a lot of time, Ms. Lord.
Sir, first, sir. Just a minute, sir.
Yeah. Yeah, already your time, you are wasted a lot of time.
We
Many
can't
people.
share PPT.
Yep. Are you not able to upload?
Just a minute. Okay.
Yeah, yeah. Okay, proceed then. Go to the slide.
Okay. Introduction. Due to
Yeah.
the variety of
See,
applications.
see, one thing. First, listen to my instruction. Already
Okay.
time is up. You go to your results and directly present your results. Uh, all these things, it takes time. Already time is running short. No? You are already taken a lot of time. Go to the presentation mode and briefly explain what is the objective of this work, and you show me the results and explain the results. That much is enough for us to assess you. Go to the slide mode. Slide mode. You press bottom that PowerPoint slide mode. It comes to the full screen. Then I can see. Yeah, yeah. There, bottom. 80% before one symbol is there. There you press. Right side bottom. 80% symbol is there, na? There, left side of that you press. It will go to the presentation mode. On your PPT, right side bottom.
Okay. Just a minute. PPT.
Uh,
Okay.
Not that one, not that one. Next, 80%, next to the 80% left side. Here, minus side, minus side, minus side. You press the symbol. Yes. Press that. Not that symbol. No. Just 100% next to that one symbol is there. Na? That symbol is the presentation symbol.
ये वाला ना?
Yes. ये वाला नहीं. You press that. Okay. If it's not working from your side, simply you explain. We'll go to the time is already. We are running short of time. You have already taken a lot of time. Yes, you proceed. Proceed
The
with
slow
your work.
evaporation method was used to generate a single crystal the- with 1% mole NaCl2 and 6 mole% glycine. Powder XRD diffraction shows impaction in doped KHP. Lattice parameters of the lattice was found to be fair agreement with JCPD card number. UV visible spectrum ensures good optical transmissions over whole visible spectrum. The value of optical energy band gap of doped KHP crystal is 4.13 electron volt. The spectrum of FTIR demonstrates existence of the functional groups in both pure and NiCl2 glycine doped KHP. Dielectric constants it varied due to the inconference of dopant inside the KHP crystal. It implies that the crystal has better optical quality and his character is essential for optoelectronic devices.
Yeah, show me your results. Go to the free 2 slides back. This is your result screen. Go to the next screen. No, before
And
screen.
that
Before.
here,
Next. Yeah. Next one. Yeah. Yeah.
accept.
Okay. Yes. Okay, I understood. Understood your work. Now you answer some of my questions.
Yes, sir.
Uh, See, what is the basic application of this material, the so-called nickel chloride doped potassium hydrogen um, pellet crystal? What is the basic application of this material? For what purpose you want to use?
It is used in optical computer, communication, data storage. Mainly, it is used optoelectronic devices and non-linear property. Because of non-linear, it is used in laser also.
How did you know what is the method you used for synthesizing this material?
Slow evaporation method.
Okay, okay. I already assessed you. Now you can leave the thing.
Thank you, sir.
Next to Srimati B. Is there Srimati B? Okay. Srimati B. Is there Srimati B? No Srimati B. Next goes to this one. Miss Sujata Bade. E1006. Miss Sujata Bade. Miss Sujata Bade. Is there? Sujata. Okay, we are getting. Next one, Rajeshwar, Mr. U. Rajeshwar.
Yes, sir, I am here, sir. Are you audible?
Yeah. Please,
Okay.
let me make you presenter.
Okay, sir. May I share my video? It's visible?
Yeah, no, wait.
Okay. So may I share my video?
Wait for a while.
Oh,
Now, who is Manjula? Breakout session. No, see, join. No. Volunteer. This Bob. Volunteer. Yeah, this one. Please come. See, this parallel session is started. One is going on 3A. We can join later, no?
Yes, sir.
Where is that? We are supposed to go there.
Through the-
Sir, Suddenly this has come, this close. Okay, now I have to go to that session, right? Not 3B. First of all, I have to complete 3A. Please, I have to complete 3A first. Yeah, I have to complete 3A. This case is supposed to give now. I have to come out and again re-enter. No, this is 3B. 3B students are here. Now I supposed to enter 3A. Close that. Yeah, suddenly. Yeah. Oh, that is automatic. Switch over. Yeah. Okay. Now, Mr. You Rajeshwar.
Yes, sir. I am here, sir.
Point.
May I share my video, sir? It's audible, sir?
Very good.
Okay.
Why? One is echo. Echo is coming. No, Rajesh.
Wait a second, sir.
Ah.
Wait a second, sir. सर ईशान एडमिट करना रिक्वेस्ट आई है हो गई एडमिट हाँ
Now we have to switch. Switch to. No, that is a different session. No, agree now. Excuse me. Babu. Hi. Okay. Make introductions. Miss Preeti. Quite some time, please stop your presentation, and then we will come back to you. This is moving to something else.
Oh, this is session third C, sir.
It is switch over to the
Join the session.
Raj. Student.
He is also presenting. Wait a minute, sir. There is issue in your laptop. It is showing two sessions.
Yeah. Again, I have to take name.
Okay.
Okay, proceed with this.
Join meeting. एडमिट कर विशाल एडमिट कर आ गया ओके 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 पार्टिसिपेंट्स शो वर्कआउट सेशंस एक सेकंड हाँ सर एक सेकंड देखते हैं नो सर ट्राई
Mine is appearing twice here in here.
Sir, I don't know what's the problem, but I will explain the solution. How's the girl was stop speaking?
Okay, I switch over. Parallel session. No, this is 3A.
Session 8. So you are in parallel session 8.
Oh, yes, I must be 3A now.
Sir, these all are the parallel session A students.
Okay.
Now take to this and
No, wait.
wait a second.
Go to Rajeshwar. No, deselect.
Wait a second, sir. मैं आपको एक बार co-host करता हूँ.
Echo is coming.
Now there is an issue or not? Echo is coming or not?
Hello?
Hello. Yes, sir.
Yeah, wait.
Okay.
He is a presenter.
Yes.
Now you can change by clicking on three dots and
This
then
fellow, Rajeshwar.
he is a presenter only.
Yeah, proceed, Rajesh.
Okay, sir. Okay, sir. I will share my screen. This is visible, sir? My presentation. Everything is okay, sir. My audio and screen.
Yes.
Okay, sir. This is U. Rajeshwar, research scholar from University of Madras.
Yeah,
And,
yours is.
nice start, sir.
Yeah. It is resounding.
Hello.
Oh, yeah, resounding from.
Am I audible, sir?
Okay. Go to the full screen.
This is in the full screen, sir.
But here.
Okay.
Okay, proceed.
1 minute. Now it's visible, sir. Now it's visible, sir?
We have to decrease this size. Which one? You all seven? Yeah, no. Okay, proceed.
Okay, sir. This is U. Rajeshwar, research scholar from University of Madras. And today I'm going to present my work entitled Exploring the Nutrient Capture Efficiency of Activated Biochar.
What is your number?
Sir, F10003, sir.
Okay, proceed.
Okay. This is the outline of my presentation. And let us start the presentation with a short introduction. We all know that agriculture is the backbone of India. And but unfortunately, due to the overpopulation, which leads to the food starvation, people prefer to increase the food productivity. So in order to increase the food productivity, people rather than using the natural manure, people used to prefer the chemical fertilizers like NPK compounds. But unfortunately, the chemical fertilizers are not completely absorbed by the plants. Some of them are remaining unabsorbed on the soil. So they are flooded through the nearby aquatic system. And this process is considered to be the fertilizer leaching or surface runoff water pollution. And this is the major issue which kills the aquatic animals, and also it creates a negative impacts for the human as well as. So we need to find the solution. In this work, I did a very simple and cost-effective solution in the NPK fertilizer by adding the activated biochar, a highly porous material where the pores present in the surface of the activated biochar is going to act as the reservoir, and which is going to capture the nutrients to prevent the surface runoff water pollution. Let us see how this happens. First of all, the activated biochar is prepared by two-step process. In the first step, the source material is carbonized, and in the second step, the carbonized sample is activated. Simultaneously, the NPK fertilizer solution is prepared by the source materials like ammonium nitrate, single superphosphate, and potassium salts. And now the prepared activated biochar is mixed with the solution vigorously for 1000 RPM to produce a homogeneous mixture using a mechanical stirrer. And in this process, the NPK nutrients are going to sit back in the pores of the activated biochar, right? And here we are going to validate the results and discussion. You can see here this is a structural analysis of biochar using XRD. You can see the spectrum, the distorted spectrum itself reveals the presence of amorphous structure of the carbon. And there is a broad hump in the region of 24 degree, which reveals the presence of amorphous carbon. And there is a small hump in the 42 degree, which reveals the presence of graphitic form. So the presence of both the amorphous carbon and the graphitic form is combinedly called as turbostatic structure. So we can able to say that the biochar is in the turbostatic structure. And the next one is the elemental analysis of NPK fertilizer solution, which is taken between the mid-IR region. You can see the many large number of absorption bands, and each and every absorption bands, it denotes the functional bonds or functional modes of the NPK nutrients present in the sample. And next, the thermogravimetric analysis. Usually it measures the mass loss to the different temperature. Here there is a slight mass loss at this region of 150 °C. This is due to the moisture loss. And finally, we received the residual mass of 88.92%, which denotes the biochar is highly thermally stable, and which can able to withstand in any atmosphere or ambience. And finally, the surface area of the activated biochar is measured by the BET analysis, which follows the BET theory. Here we substituting all the values, obtained values in the formula, we can able to get nearly 7.7070 meters square per gram surface area. And finally, this is the SEM analysis, SEM image of activated biochar. You can see the many surface pores, and here is the cave-like structure which is going to capture the nutrients. And this is the SEM image of the NPK fertilizer. Many crystal structures denotes the presence of NPK nutrients. And this is the final image of the composite, where you can see that there is a dark surface, which is the pores present in the activated biochar, and where the pores of the biochar, which is successfully capturing the nutrients on its surface. And finally, the SEM analysis not only validated the nutrient capture efficiency of biochar, but also underscore its water retention capacity, showcasing its potential in agricultural land environmental context. And this finding lays a solid foundation for the future research endeavors aimed at enhancing the performance and versatility of biochar. So thank you, sir.
Yeah, Rajeshwar.
Yes, sir.
Here,
Yes, sir.
which example you are
Okay.
taken for this study? Material. Which nutrients
So
you are, on which on
I
which
preferred.
nutrient?
Okay, okay.
See, the title is very vague.
Yes,
Exploring
sir.
the nutrient capture. Which nutrient? Have you studied many nutrients or only few
No,
nutrients
sir.
or any one
One
particular nutrient?
particular nutrients, sir. Especially ammonium nitrate and phosphates, single superphosphate. Because they are the major giving major contribution to the NPK fertilizers.
Okay. What is the novelty? This kind of work already some studies are there.
There is no detailed studies, but here what I am presenting is not a full complete work of my presentation. But there are some of the works which playing some composite role for the activated biochar and the NPK nutrients.
Okay, Rajesh.
Okay, okay, sir.
Okay, you can leave Rajesh.
Okay, okay, sir. Thank you.
Next, Tanu Sri Dev. Yeah, Tanu Sri. Tanu Sri. Tanu Sri Dev. Amit Patil. Amit Pat. Amit Patil.
So excuse me, sir.
Yeah.
So instead of Dr. B. Srimadi, as a co-author, I am going to present. So shall I present? Actually, my chances already get over. That's why again I'm asking.
So is it Amit Patil?
No, sir. Dr. B. Srimadi. Paper ID is E10004.
Please repeat your.
Dr. B. Srimadi, sir. Paper ID is E10004.
No, that is already gone.
No, sir.
Plus,
I am unable to present. That time it's in
no, please
Shall I
wait.
start now, sir?
Resounding. Please wait. Maybe in the
Okay, sir.
after the resound, suddenly somebody is entering and asking all these things. What is this?
You are previously in which 3B or in which 3A? क्या हुआ क्या हुआ विषय
Amit Patil is there. It is getting resound. Somebody is without our permission. They are displaying.
mute all mute all okay sir
Hello. It is resound.
hey wait a second
Echo is there. Remove any one of them. Focus.
now it's so clear
Hello. Yeah, now it is. Hello, Amit Patil. Dr. B. Srimati, please, we will call you back. You exit. No, we will give you the opportunity once again. Now let me proceed with the ascending order. I cannot suddenly come back to you. Now the time is for Amit Patil, Mr. Amit Patil, F10008. Mr. Amit Patil is there.
Okay, sir. We'll wait. Thank you.
Okay. If Amit Patil is not there, then he will switch over to the another fellow. Next one is Riya Sadhu Khan. Miss Riya Sadhu Khan, F1009. Miss Riya Sadhu Khan. Miss Riya Sadhu Khan. No, that and later. Because we called many times. Miss Riya Sadhu Khan is there. Next. Hemant Kumar. Mr. Hemant Kumar. Yes. Mr. Hemant Kumar. Not coming.
Click on unmute. Then make presenter. Now
We have to unmute and
make presenter. Now he will unmute himself.
present it. No?
Yes, sir. Now he will unmute himself and present.
Okay, Hemant Kumar. Please unmute and upload your PPT.
Yes, sir. Can I audio?
Yeah. Please present your thing.
Yes, sir. Good afternoon, sir.
Yeah, good afternoon.
Sir, it is visible.
Yeah.
Sir, my PPT is visible now.
Yes, your name is displaying. Your PPT is not.
Sir, it is visible my PPT.
Yeah, proceed further. Only your name is.
Sir, my PPT on the topic post-odontic application of PMMA, which
No,
is
no. It is not visible, Hemant. It is not
okay, sir.
visible.
Wait a minute, sir.
Please upload your PPT.
Sir, now,
Yeah.
sir, now my PPT is visible.
Just you proceed further. Only you are showing me your email.
Yes, sir. Okay, sir. Thank you. Sir, now my abstract is on you.
No, not yet.
Sir, wait a minute. So now my PPT is showing.
No, not yet.
Just a minute. Give me a minute. So now can I share?
Yes. Go to the full screen. Enable editing. Top option is there. Enable editing.
But it
And
is
go to
visible.
the-
My PPT is visible.
Yes, visible.
Okay,
Proceed
sir.
further.
Sir, my topic is on that post-odontic application, which is
Go to
PMMA.
the full screen. Go to the full screen. Full screen mode. Enable editing. There. Top. Enable editing. Yes. No, what is enable editing? No, there. Top right. It is up.
Okay.
Yes. And go to the full screen. Yeah. You press bottom right. One PowerPoint presentation mode. Bottom right. Bottom right. PowerPoint presentation mode is there. Na? That symbol you press, it will go to the full PPT mode.
But this is now from my side. This is my full screen.
Go to the slide mode, PPT mode.
Okay, sir.
Presentation mode. Do it
Yes.
quickly. The time is running short.
Yes, sir. My abstract is that polymethyl PMMA is commonly used in biomaterials, which is easy of manipulation, aesthetic properties, and PMA has been used for the fabrications of artificial teeth, that is, operators, orthodontic retainers, and further advancement in PMA biomaterials. It is likely that this material will continue to be important component in the field of orthodontics.
Yeah, that's fine. You explain. Not, don't read the PPT. First, you explain the problem objective, and
Yes, sir.
then you present your result. And within 5 minutes, you have to complete it. You should
Okay,
not
sir.
waste your time.
Okay,
Question
sir.
and answer.
Okay. In short form, I can present my PPT, that is applications where PMMA, which is used in biomaterials like artificial teeth, denture bases, denture operators, and repair of dental prostheses. This is the uses or applications we can say. And advantages of this is that biocompatibility, PMMA is biocompatibility and well tolerated by the body, which is safe and secure for our manufacturing process, post-treatment
Yeah,
process.
that's fine. Go to your result.
And next one is chemical structure. Chemical structure, the molecular weight of PMMA can range from a few thousand to several million. And the types of polymethyl is buck PMMA, cast PMMA, which is used in journal method, or this is the PMMA denser based materials. And PMMA CAD CM restoration. CAD means computer aided design, and CMA, which is computer aided manufacture, which is scanning, designing, milling, finishing. These are the PMMA implant prostheses. And PMA for maxillofacial prosthesis means impression, designing, fabrication, attachment, which is this is the table of my application which is used previous. And these applications beyond I can explain when I started my presentation. And the limitation is that, sir, PMA has limited translucency, which can limit its use in certain prosthodontic applications. PMMA can brittle and prone to fracture under certain conditions. And polymerization shrinkage, PMMA undergoes polymerization shrinkage, which can lead to inaccuracy in the final prosthesis. This and the future direction of the development in PMMA biomaterials, which is improved in mechanical properties, reduce polymerization shrinkage, enhance translucency.
Hemant,
Yes,
show
sir.
me your results. Don't read all this text for us. Is it? Is there any work here? You are simply copy pasting this one. Where is your result?
My result is that the conclusion is that PMMA biomaterials have been used to fabrication of various dental, which is we commonly used in biomaterials to artificially teeth, denture bases, etc. This is the conclusion at last we saw by me. And with continued advancement, PMA biometric, it is likely that I will remain an important component in the field of prosthodontic. That at high quality, durable, aesthetically pleasing dental prosthesis. This is the my result at the last conclusion, which is different from that.
Okay, is it review paper or it is a work paper?
Sir, review paper, review paper.
Review paper.
Yes, sir. I am in the MSc final year, sir. Second year.
Which year?
MSc second year. Final,
How?
sir. Review paper, sir.
Okay. Are you BTech or MTech student?
Sir, MSc, Master of Science.
Okay, MSc student.
Yes, sir.
Okay.
And last, these are references from where I help from these papers. Like after conclusion, references are there, like these.
Okay. Okay, Hemant. Okay.
Okay, thank you, sir.
Raj Kumar,
Sir, can I stop sharing?
yes, you can leave.
Okay, thank you, sir.
You can leave. Dr. Raj Kumar, G10001. Synthesis of bio waste. Dr. Raj Kumar. Is there Dr. Raj Kumar?
Hello?
Yeah, Dr. Raj Kumar, you can present.
Yes, sir. Yes, sir.
Yeah, please.
I'm sharing my screen, sir.
Yeah, please share. Please.
Is my screen is visible, sir?
Yeah. Proceed.
Good morning, good afternoon, one and all. Myself, Dr. Raj Kumar. I'm working as assistant professor at SR University, Warangal. My title of the paper is Synthesis of Hydroxyapatite from Bio Waste. My contents of my paper are introduction, methodology, results and discussion, and conclusions. Slide is not changing.
You press enter, otherwise.
Yes, enter. Not changing.
Maybe some network issue is there from your side.
No, sir. Wi-Fi is signal is good. Yes, sir. Now it is.
Yes, please do it.
Synthesis of hydroxyapatite from fish bone, sir.
No. This side is not loaded fully.
Not loaded?
Not loaded.
Is it visible, sir?
No, not yet. Only your video is visible. Yes, now it is coming. You close your video. Maybe some network or bandwidth problem might be there. You close your video. Only show me your presentation.
Okay.
Close your video. Yeah. Now you can proceed further.
Yes.
Go to the presentation mode.
Hydroxyapatite is a naturally occurring mineral with a composition of CA5PO4 trice and OH. It is a mineral component in vertebrate bone and teeth.
Yeah, go to the presentation mode. Actually, you are showing in different. You are opened multiple applications. One word you are opened, one background is opened. Yeah, now you can proceed. And you tell me your objective very briefly.
The main objective of my work is to prepare hydroxyapatite from bio-waste materials.
Yeah.
Most of the people are worked on the preparation of hydroxyapatite with the different methods like solid state method and with the chemicals. In the project is we have prepared with the help of bio waste. That is with fish bone we have prepared. Fish bone with the help of simple conventional melt quenching technique. Since fish bone is consisting of since fish bone is a biocomposite of hydroxyapatite and collagen. The content of hydroxyapatite is major part and collagen and other contents are minute. With the help of heat treatment, we can remove the inorganic organic components and we can get the hydroxyapatite from the fish bone.
Okay, now go to the
Yes, the methodology. The preparation method for the preparation of hydroxyapatite is fish bones were collected from local market and collected bones were cleaned in boiled water to remove the unwanted organic content in the oven at 100 degrees for 12 hours. Then these cleaned fish bones were retreated at 900 degrees for 6 hours at a heating rate of 2 degrees per minute. After that, the fish bones were grounded for fine powders. After the preparation of these powders, these are characterized with different techniques. TGDTI results were showing that there is a less weight loss of 4.3 percentage up to 900 degrees. There is less weight loss because of processing conditions, and the stability. Therefore, the prepared ceramic materials thermally stable. And this is the diffraction micrograph of prepared material. These peaks were indexed, and these are matching with the standard JCPDS data of a synthetic hydroxyapatite. From this, XRD is confirming that the material which is prepared from fish bone is resembles the hydroxyapatite. And FTIR results, from this FTIR results, the bands at 473, 564 and 603 are related to PO bending bonds, and the band at 962 and 1063 are stretching bonds of phosphate groups, and the shoulder at 875 and the peaks at 1412 and 1458 are related to carbonated type. 875 is a A-type carbonated apatite, and 1412 is a B-type carbonated apatite. And the bands at 666 and 1640 are related to OH bonds. From this, phosphate content is there, carbonate content is there, and hydroxy group is there. From this, we can see, we can confirm this is a carbonated hydroxyapatite. These are the same micrograph. From this, the morphology of these powders are rock-like morphology, and with the elemental analysis supporting the presence of calcium and phosphorus in the hydroxyapatite powders, and the calcium to phosphate ratio is about 1.6, which is nearly equal to the calcium to phosphate ratio of human bone. From this also we can confirm whatever the prepared material is hydroxyapatite. The prepared material is XRD, FTAR and EDS results supporting the formation of hydroxyapatite. And to check whether prepared material is cytocompatible or not, we have performed MDT assay with the help of MG63 cells. MG63 cells are human bone cells. MPT, in the presence of, if you are keeping our material with bone cells, if the material is non-toxic, the cells will be viable. In that case, tetrazoline salt will be converted into parmesan crystals in metabolically active cells. The methodology for the MTT assay is different 5,000 cells of Mg63 cells are added to each 96 well plates, and these cells were incubated for 24 hours. After that, different concentration of testing material is added for the cells for 48 hours. After that, 12
Okay.
microliters of MTT
Yeah,
solution
yeah,
will be
yeah.
added.
Yeah, yeah.
With
Fine.
this procedure, we can measure the cell viability. These are the cell viability results from 50 microgram per ml to 1 mg per ml. Different concentrations were treated. Even for higher concentration also, cell viability is around 90%. As per the ISO standards, if the cell viability is more than 70%, those materials are said to be cytocompatible materials. And this is also one of the evidence. Or we can observe the presence of parmesan crystals, and this right side image, we can see the live cells with flake-like structure. Even at a higher concentration also, we can see the flake-like structures. I mean, this is also one of the evidence of cells are viable in presence of mild material.
Okay, fine. Yeah, you can proceed conclusion and continue.
As natural hydroxyapatite has been prepared by from fish bone with the heat treatment method. XRD supports the well crystalline hydroxyapatite formation. FTR also supports the characteristic peaks of hydroxyapatite, and even with the help of CA, calcium to phosphate ratio also supports the formation of hydroxyapatite. MTD result supports the non-toxic nature of the material. From this, we can say the prepared powders are non-toxic hydroxyapatite powders.
Okay. So what is the major, Dr. Rajkumar,
Sir,
what is the major application of your work?
actually, hydroxyapatite is used in different applications. It is used for bone and teeth, for maxillofacial applications. It is used as a coating in uh, different. Sorry, it is used as a coating material, and it is also useful for filling applications. Generally, instead of chemicals, we can use bio waste. Already, we can make a material from the waste, which is useful for biological applications.
Okay. So this is a PhD student work.
This work was done by me during my PhD.
Okay. Now you are presenting.
Yes, now I'm presenting.
But meanwhile, there are many advancements also there, na, in this direction.
Advancements in the sense of what, sir?
Recent papers, and already some papers also there here.
Some papers also there. This work was it's a long back paper, and we are making nano materials with this. This is a simple synthesis method only I presented. Some other work, some different applications are there. I am not mentioning that applications.
Okay. 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 You can say. So now, Miss Komal Korea. Miss Komal Korea is the. Okay. Rajkumar, you can say.
Okay, thank you, sir.
Miss Komal Korea.
Hello.
Yeah. Yeah.
Yes, sir. Kamal Korea here.
Yeah. Please present.
Sir, my screen is visible.
Yes. Yes. You proceed further.
Okay. Myself, Komal, and I'm presenting my paper presentation on glass transition behavior and structural analysis of strontium chloride modified telluride-based glasses. Telluride glasses have interest due to their have low glass transition point and high dielectric constant and high refractive index. In telluride glasses, they are
Yeah. Your PPT is not visible. Please, your PPT is not visible.
just a minute, sir. Share. Uh, is this visible, sir? कौन सी होगी ये? PPT fully हो रही है. Sir, my PPT visible? Okay. Okay. Telluride glasses are conditional glass former that easily form glasses with modifiers such as alkali, alkaline, and transition metal oxide. Additional boron oxide, tellurium improve the glass forming ability and enhance the thermal stability. Telluride halide glasses are suitable for infrared transmitting material or information and energy transmitting optical fibers, which may be used for thermal image guideline on contact temperature and light guide carbon dioxide lasers. Material synthesis. Melt quenching methods used to synthesize these glass samples. First, we have selection and weighing the sample, and then batch will be formed. After that, quenching and annihilation process, we have formed glass. Result and discussion. In the result and discussion, we have first is thermal differential thermal analysis. In this, we have this figure shows